All right, I'm going to run you through how to do some calculations for water supply. So here in our diagram we have a pumping station. This pumping station gets water from the water treatment facility and pumps it up into the water tower. The water tower, it's dispersed through another series of pipes to the consumers, in this case our residential area. A couple of things we need to know. First of all, we need to know the water tower elevation. And so I'm just going to draw a line. I'm going to write out here that the water tower elevation it is 800 feet. Down here we are going to label the site elevation. Our site elevation is 700 feet. And the last thing we need is our discharge elevation. So our discharge elevation is the elevation that the water is going to be discharged in the home. And so we will say in this case our discharge elevation is going to be 6 feet. I'll go ahead and write discharge elevation. And so what that means is that the water comes into the house at 700 feet and it's discharged at the faucet at 6 feet higher than that 7 feet. And a couple of points of clarification, this 800 feet and 700 feet are measured from sea level. And so our water tower isn't 800 feet tall. Just a couple of things that we need to know. The other things that we'll write down, the knowns that we'll write down, let's go ahead and write knowns up here. The other things that we need to know are how far the water tower is from our discharge point. And we're going to say we have 5 miles of 10-inch diameter cast iron pipe. We're going to say that we have in that pipe, it includes 5 90-degree elbows. So what a 90-degree elbow is to turn a pipe around a corner. It's just a 90-degree turn, and so an elbow is a way that you can turn the pipe 90 degrees so the water will flow 90 degrees from where it was at. And we're going to have one 45-degree elbow in our piping system. And the last thing we need to know is the flow rate of the water coming from the water tower is going to be 120 gallons per minute. So those are all the knowns we need. The first thing that we are going to calculate is called static head. It's measured in feet of water, and what it is, again, is the amount of water. If we were to put a cylinder on this type, if this volume of water will raise that water, how many feet will it raise it? And so static is just static head is just a steel calculation. All right, and so if we look at our formula sheet, we will see that static head, We'll go ahead and write this down. Look at our formula sheet here. Static head is equal to the change in elevation between the source and discharge. So we'll say static head is equal to the water tower elevation minus the discharge elevation. So static is, the water tower elevation is 800 feet minus the discharge elevation. So our discharge elevation is 700 feet, and we have to add in another 6 feet for that. And so our discharge elevation is 706 feet. And so you subtract 800 from 706, and you get a static head of 94 feet of water.